you all wrote about the postulates of KTG. Postulates of KTG, or you can say that it's assumption. It's assumption for ideal gas equation, for ideal gas. And from this assumption, we got ideal gas equation. Ideal gas equation. And what was our ideal gas equation? PV equals to nRT. Is that clear, Saif?
Yes.
Yes.
Yes, you need to remember this formula PV equals to nRT. The first postulate or the first assumption says that gas consists of large number of identical particles which called atoms or atoms or molecules. Basically, the gaseous particles are very far away from each other, and they are very large in numbers, and each particle is called atoms or molecules. Like if we have gas, argon gas, or you can say helium gas, that means they are each particle is called atom. And if I have gases of nitrogen exists in N2 form, so the gas particle can be called molecule. So gases can be molecule as well as atom. The second postulate says that considered that according to the second postulate or assumption, it considered ideal gas as point mass. Ideal gas as point mass. So the volume of ideal gas is negligible in comparison to the volume of container. So here the second postulate or assumption says that ideal gas is treated as or considered as point mass. So for point mass, the volume is negligible. Volume is negligible. So we just compared the volume of container. We just compared the volume of container to volume of ideal gas, and the volume of ideal gas is negligible in comparison to the volume of container. Is that clear? Saif?
Yes, sir.
Yes.
Etasham?
Yes, sir.
Okay. So again, I am going to say that ideal gas is considered as point mass. So volume of point mass is negligible. So we just compare the volume of gas to the volume of container. Second postulate, third assumption is that we know that from universal law of gravitation, every objects attract every other objects. Is that clear? Is that right?
Yes.
So according to universal law of gravitation, the gas particles should attract each other. But here in assumption, for ideal gas, there is no force of attraction present between gas molecule. So if you read this statement, it's all assumption for ideal gas. Okay, so you just need to remember it for ideal gas. Okay, and the fourth postulate says that all gases particles are is in constant random motion. They are in random motion. They travel in a straight line in all direction and collide with the wall as well as with each other. The collision will be elastic collision, perfectly elastic collision. Have you ever heard of it? Perfectly elastic collision or inelastic collision? Ifra, Etasham, Saif, please speak up.
No, sir.
Okay. So when you will study center of mass in physics, you will come to know about elastic collision, inelastic collision. Okay. So the next postulate is gas particles are perfectly the collision between gas particle and the wall is perfectly elastic. And the next postulate is when the gases move, they move in a straight line. Okay, it's all postulate, it's all assumption. it's all assumption. You just need to memorize it for a while. Okay. And the last postulate, which is very much important, says that kinetic energy is directly proportional to the absolute temperature. If we increase temperature, kinetic energy will also increase. That means the gases will move with more velocity, the speed will be increased. As we know that kinetic energy equals to half mv square. And if we are increasing temperature, that means kinetic energy is increasing. And you can see that mass of gas will not change. Mass of gas is constant or not? Mass of gas is constant. So what kinetic energy depends on the factor velocity. So if we are increasing temperature, that means kinetic energy increase. That means velocity increases. That means the speed or velocity of the gases will be more and will be increased. Is that clear?
Yes.
So it is very important. Now we are going to discuss about Maxwell distribution curve. Maxwell distribution curve. If you have any doubt in any of these assumption, please let me know. Okay. Saif, Atasham, and Ifra. So do we move to the next topic, Maxwell distribution curve? Atasham, Saif.
Yes.
Okay, thank you.
Yes.
Okay. Maxwell distribution curve. It is based upon probability factor. It is based upon probability factor. It is based upon probability factor. Now we have some points or postulate regarding this. So I am writing it, and please write with me, then I will explain it. And if you will have any doubt or any type of query regarding this point or the previous one, you can ask anytime. The fraction of molecule with higher speed as well as lower speed is less in number. And the postulate which I am writing is in very easy language. You can easily understand it. The fraction of molecule, just suppose 100 molecules in a container moving with moving with some speed. In that container, the fraction, the molecules which are moving with higher speed will be lesser in number, as well as the molecules which are moving with lower speed is also in less in number. So on an average, the molecules which the molecules which has a speed in between higher and lower will be more. Is that clear?
Yes, sir.
Yes, sir.
Okay, thank you. Moving to the next, the velocity possessed by maximum fraction of molecule is called most probable speed or most probable velocity. And it's too easy to understand that if there are 100 molecules in a container, if there are 100 molecules of a gas in container, and let's say 70 molecules of gases are moving with the same speed, that speed will be called most probable speed. Is that clear? Etisham, Saif.
Yes, sir.
So, and it is also known as MPS, most probable speed or most probable velocity. You can say that. Okay. So, moving to the next point, the velocity of molecule. The velocity of molecule changes with progress of time. So it's also too easy to understand. The velocity of molecule changes with changes in time. With time, the velocity of molecule also changes. Just write it and let me know if you are finished with this.
Yes, sir. Done.
Done, sir.
Done.
Yes, sir.
Okay. Thank you. Is there any doubt in this in these 3 points? No. Saif, Etasham.
No.
No, sir. Yes.
Okay. Thank you. Now, here is a formula for you, and listen to me. These topics like KTG, kinetic theory of gases, and Maxwell distribution curve. There will be derivation in class 11th in the same class you are studying. In physics, you will learn about it more and more in physics. Okay, so I will write the formula directly instead of deriving it, because you will get to know about in physics. Okay.
Yes, sir.
Okay, so here is a formula. Average first you write average kinetic theory of gases. ठीक है, average kinetic theory of gases, or you can say average kinetic energy. You just write it average KTG. Okay, now you will get a formula. PV equals to 1 by 3 m into n and c square RMS. RMS is in subscript, that represents root mean square speed. I will explain each and every later in this. P is pressure. P is pressure. V is volume. V is volume. And here m is mass of each particle. Mass of each particle. And n is equal to number of gas molecule. So if you know the number of gas molecule and mass of each particle, that means let's say there are 100 molecules of gases, and each of mass that is 10 gram. So how what is the total mass? That will be 100 into 10. That will be equal to 1000 gram. So basically this represent total mass of the molecule. Okay. And here Na, that will come in the next. Na is Avogadro number. This is very important, Avogadro number, as you know that. And C square RMS, basically this RMS represents a root mean square speed. Root mean square speed. There will be three types of speed: root mean square speed, most probable speed, and average speed. And we will uh, have formula for each of them. Just write it.
So what is the above thing you have written there? 100 into 10 equals 100 gram.
That represents, I just took an example that in a container, if 100 molecule of gases are present,
Yes.
okay, and each gas and the mass of each gas is 10 gram. Okay, so total
Yes.
mass is 100 into 10, that is equal to 1000 gram.
Yes.
So here mass m represent mass of each gas and n represents number of gas of molecule. So if we multiply these numbers, this m into n, what does it give? Total mass.
Yes, sir.
So write it.
Done.
Done, sir.
Okay, Saif.
Sir, that Na is not in the equation, right?
Yeah, yes. If we will talk about per mole, then we will multiply by it. Na is just not Na is not present here. Okay.
Yes, finished.
Now you can see PV equals to 1 by 3 m into Na into C square RMS. Just listen to me carefully. M is mass of each gas. Na represents 1 mole. That means if in a container there will be 1 mole of gas, that Na, what Na stand for? 1 mole. So here n is number of molecules of gas, and here Na represents exact number of molecules, that is 6.022 into 10 raised to the power 23. Is that clear?
Yes, sir.
Saif, please let me know.
Yes.
At the Sham.
Yes, sir. Clear.
Okay, just write the another formula for this.
Sir, this equation will be used
Yes,
if we know the exact number of moles.
yes. This equation is for n represents any number, and Na represents basically 1 mole. Okay.
Yes.
Okay, thank you.
Done, sir.
Done. Can I change the slide, Saif, at the Sham?
Yes, sir.
Yes.
Okay. Come to the another formula we are going to have. Basically, you know that 1 mole is equal to Na, or we can write Na is equal to 1 mole. Everyone.
Yes, sir.
Yes.
And 1 mole is also equals to we can say 1 mole is also equals to 22.4 liter.
Yes.
Saif.
Yes.
At the Sham.
Yes, sir.
And 1 mole is also equals to molar mass. Molar mass. Is that okay with all of you or not? Let me know. I will prove it. How 1 mole is equal to molar mass.
The molar mass, mass divided molar mass, right?
No, 1 mole equals to molar mass.
Sir, how, sir?
Ifra,
Yes, sir.
Saif,
Sir, how, sir?
Saif.
Yes.
1 mole equals to molar mass. Is there any doubt in this? How does it come? 1 mole equals to molar mass.
Yes.
Okay. See here. If you are going to find number of dozen, how many number of dozen? What you do is divided by 12. Any number divided by 12, that gives number of dozen.
Yes, sir.
So if you are not getting it, I'm just asking a question. Please let me know the answer. Okay. If I am saying that 60 pence, how many dozens?
Maybe 5 dozens.
Saif, 5 dozens. How does it come? Basically, number of dozen equals to what you just did, 60 by 12, and it comes out to be 5 dozens. Okay, is that clear?
Yes.
So why you divided it by 12? That means 1 dozen equals to 12. That's why you divide it by 12. Okay.
Yes, sir.
Yes.
Now you see, number of moles is equal to given, I will take the example of mass in the last. Number of moles is equal to given number of particle upon Avogadro number. Do you remember the formula in the first class that you took,
Yes.
Saif?
Yeah. Yes, sir.
Okay, that means one mole, n represents number of moles. Okay, that means one mole is equal to Na. And I have given you another formula. If volume is given, that will be divided by 22.4 liter. That means one mole must be equal to 22.4 liter. That's why we we have a formula that represents that is given volume upon 22.4 liter. Another formula, the third one, which is very much important, n is equal to given mass upon molar mass. Is that clear?
Yes.
If you are dividing it by molar mass, that means 1 mole is equal to molar mass of the given substances, of the given compounds, molecules, or atoms. Is that clear, Saif?
Yes.
So I can write 1 mole is equal to Na, 1 mole is equal to 22.4 liter, 1 mole equals to molar mass. Okay. Now it will it be okay?
Yes.
Okay. I just explained it. I am changing the slide. Okay, you already wrote all about this in the previous
Yes, sir.
classes in the first lecture. Okay, come to this point. PV equals to, we have 1 by 3 m into Na into C square RMS, and we can also write PV equals to 1 by 3 okay, m C square RMS. For I'm writing it, Na represents 1 mole. Is that right?
Yes.
And m represents mass of each particle. So if we multiply it by 1 mole, we will get number of molar mass or total mass.
Yes.
Saif, Tasham. Okay,
Yes.
so this is the modified form of the previous equation. Okay, concentrate here. PV is equal to, I am multiplying it by 2 and dividing it by 2, and we get mc square RMS. I can multiply and divide with the same number according to maths.
Yes.
So what we get here, PV is equal to, just concentrate here. If you will see it, half mv square, doesn't look like the half mv square. What does this represent? Mass. And what does this say? C is what? Speed. I just wrote in the previous slide that C square RMS, that represents root mean square speed. In the end, I wrote speed or velocity. So we can easily write it. PV equals to 2 by 3, and this is Ke, kinetic energy. And you can also write it, kinetic energy equals to 3 by 2 P into V. Okay, everyone, please do reply. Then you will write. Okay.
Yes, sir.
Now see, as we know that PV equals to nRT, so we can easily put nRT instead of, as um, we can easily put nRT in the space of PV. Kinetic energy equals to 3 by 2 nRT. We can write or not?
Yes, sir.
And for 1 mole, for n is equal to 1, that represents 1 mole, kinetic energy will be equal to 3 by 2 RT. And here we got kinetic energy directly proportional to temperature. Kinetic energy directly proportional to temperature for n moles. You can write. So please write it and read. it once and let me know if you have any query about this.
Sir, how M and N number of moles got capital M molar mass? How did it get changed?
Very good question. uh, Ehtisham,
Yes, sir.
just see Na what represent? It represents 1 mole.
Yes.
It represents 1 mole. M what represent? What does it represent? It represent mass.
Yes, sir.
And if we just apply the formula, number of moles is equal to given mass upon molar mass. Can we apply?
Yes, sir.
And here, if I'm going to write total mass, that is, you can just change it, or you can. Okay, we are not going to apply this. Okay, just see 1 mole. 1 mole. That what does it represent? It represents numbers. It represents that 6.022 into 10 raised to the power 23 gaseous molecules are present. Is that clear?
Yes, sir.
And mass of each gas is m. Is that clear?
Yes.
So in the previous slide, I wrote this: if 100 molecules are gas present and each gas has mass 10 gram, then total mass will be 1000 gram. So if Na molecules are present, 1 mole gaseous atoms or molecules are present, and each of them has mass m, then if we multiply this, then we will get total mass m.
Okay, sir. So it's not molar mass, it's total mass.
So instead of writing number and number into mass of each gas, I just wrote m. Is that clear?
Yes, sir. So this is total mass, right?
Okay,
Not
thank
molar
you.
mass.
Yes, total mass. You can say.
Not molar mass.
Yeah. Not molar mass. Done. Everyone done?
Yes, sir. Done.
Okay, Saif.
Yes.
So this formula is for kinetic energy per mole. Okay, you can write it in the bracket. Okay, we have some graphs according to Maxwell. I'm changing the slide. So this point is very important. Kinetic energy is directly proportional to temperature. Questions comes directly like if we increase temperature, then kinetic energy will be affected or not. If yes, then how much increasing or decreasing? So you can see that temperature is directly proportional. That means if we increase or decrease temperature, it will affect kinetic energy. If we increase it, kinetic energy will increase. If we will decrease temperature, then kinetic energy will be decreased. Okay, now come to the graph. This is speed and this is fraction. Wait a minute, please. I'm writing in between the slide. This is speed and this is fraction of molecules. Fraction of molecules. And the graph comes like this. Now see, on y-axis, what does it represents? It represents number of fraction of molecules. And what does it represents on y-axis? It represents fraction of molecules, and on x-axis it represents speed. So fraction of molecules, where fraction of molecules are maximum, that speed is called most probable speed. So from the point here to the here, this represents MPS. That means most probable speed. Most probable, sorry, most probable speed. Okay. And here you can write a very important point. Area under this graph, area under this curve represents or equals to number of number of gas molecules. So this is very important. If questions come like the graph between fraction of molecules and speed gives number of molecules, number of gas of molecules. Okay. This graph is also known as bell-shaped graph.
Okay, done.
Done, everyone. Very good, Ifra. Saif, what about you?
Yes.
Okay. So here is a question for you that is on graph that we have plotted in the previous slide. That is in graph between fraction of molecules versus speed. So here is a graph like this, and wait a minute, let me draw the graph, then only you will draw, because my diagram is very good. I have to erase it again and again. I'm changing the color. This is the graph. Okay, so I'm writing it this is T1. You need to write a relation between T1, T2 and T3. T1, T2 and T3. If I just think opposite whatever you thought and write this relation. I'm writing an option T1 greater than T2 greater than T3. I'm writing another option like T3 greater than T2 greater than T1. And you have to give explanation for your answer too. And option number 3, T1 is equal to T2 is equal to T3. Option D is equal to T1 very greater than T2 greater than T3. And if you are unable to think anything about this, then let me know, I will explain. Okay. Option B, explain it. You
Sir,
can write in.
T1 is temperature or time, sir?
This represents temperature, not time.
Okay.
So where I wrote kinetic energy is directly proportional to fraction of molecules. Ifra, the explanation you have given me raise another question. That where I wrote kinetic energy directly proportional to fraction of molecules. Kinetic energy directly proportional to fraction of molecules that represents. If we are increasing number of molecules, that increases kinetic energy. Is that possible, Ifra?
No.
Itasam, do you get any answer? Asaf,
I sent the answer.
what is the answer?
Option A.
Option A, very bad. What is the explanation for A? Your answer?
So temperature is directly proportional to fraction of molecules because temperature is directly proportional to kinetic energy and kinetic energy is directly proportional to fraction of molecules.
Oh. So you are saying that temperature is directly proportional to fraction of molecules. If we increase temperature, then we will increase number of molecules. You are saying it.
Yes, sir, because the heat it produces
Yes,
can break down.
listen to me. If you increase temperature and if you are boiling water, just suppose water, if you are going to boil it, and if you just increase the temperature, then water molecules will increase.
No, so it will decrease, sir.
Is it possible?
It will decrease, sir.
Okay, just see here. What is your answer, Saf?
I wrote also A.
Oh. So you tried not responding. This is very good. Bad. Am I audible to you
Yes, sir.
still?
Yes, sir.
Okay, thank you. It wasn't responding well, so I thought it's hanging again. So just listen to me, okay? So here you are seeing that T3 what does x-axis represents? A speed. It represents or not?
Yes.
Yes.
Ihtisham, Ifra,
Yes.
and Saif. Oh, so you can see that at T3, this MPS value, this speed is maximum or not. MPS 3 will be maximum. You can read graph easily or not. Can you read graph? You can see at T3, I am representing it MPS 3. At T2, I am representing it MPS 2. And at T1, I am representing at MPS 1. Let me know which most probable speed is maximum and which is minimum.
So T3 is maximum and T1 is minimum.
T1, MPS 3, that means MPS 3 here. Saif, are you getting it? Greater than MPS 2, greater than MPS 1. This represents or not?
Yes, sir.
Ifra,
Yes.
Saif.
Yes.
Yes.
So you can say, I just wrote this kinetic energy directly proportional to temperature. That means temperature increases, kinetic energy increases. If kinetic energy increases, that means velocity increases, where it is whatever speed it is, whatever type of speed it is, whether it is most probable speed, whether it is root mean square speed, whether it is average speed, it will increase eventually. Is that clear?
Yes, sir. So B is the right answer.
So answer will be T3 greater than T2 greater than T1. Everyone okay with this?
Yes, sir.
Yes, sir.
Okay, write it, and I'm writing a conclusion. Write it with me again. It is so I have a conclusion. Write with me. When T increases, all types of velocity increases, and the graph will shift towards right, towards right side. Why graph will shift towards right side? Because temperature increases, and temperature increases, so speed will also increase that way. That's why. And on x-axis, it represents the speed, so it will move on the right side. Okay, Ifra?
Yes, sir.
But here is very most important point. Area under curve remains constant. Area under curve remains constant. This area will be equal to this, and this area, the curve of that I represents T1. This is the first curve, the second curve, and this third curve. The area of three of them will be equal to each other. Okay, this is very important. This is very important. Oh.
Done, sir.
Okay, thank you. What about you, Saf?
Yes, sir. Completed.
Ittisam?
Yes, sir. Done, sir.
Okay, thank you. So, Ittisam, done?
Yes, sir, done.
Okay. Moving to the next topic related to this topic, types of velocities. Types of velocities. The first one, root mean square speed. Root mean square speed. RMS. In different books, you will get to see different symbol for it. In many books, it is written as CRMS. In many books, it is written as URMS and VRMS. We just need to know what is this root mean square speed. So it is very easy. First, just see, just take the root first, just take the root, okay, and a square of the velocities. Just see, if there are n number of molecules, that means v1 square plus v2 square plus v3 square plus dot plus vn square, we will write or not? Tell me.
Yes.
Now, for average, mean means average, and for mean value, when we calculate mean value, all the values divided by all the number of values. That means if we are going to find mean for A, B, C, okay, the mean values of their velocity, the mean velocity, if you say this is moving with velocity v1, this is moving with velocity v2, and this is moving with velocity v3, that means we are going to find v mean, that will be equal to v1 plus v2 plus v3, and the total number, how many objects are moving, 1 2 3, so we will divide it by 3. This is called mean. So I'm going to do the same with here. For mean, n1 plus n2 plus dot n times. Okay. So so the mean square speed is basically you can easily derive it from its name. Square speed, first we are going to do a square of every speed, and then mean is for add all the speeds, or add all the speeds and divide it by the number of molecules, how many molecules are moving with different velocities. So I did this, and for root I just took root. So you get a formula RMS is equal to I'm writing again it, v1 square plus v2 square plus v3 square dot and n1 plus n2 plus n3 dot. Now Maxwell gave a formula directly. RMS is equal to under root of 3 PV upon m, that represents molar mass. That is also equals to under root of PV equals to nRT, and for 1 mole it will be RT upon m. This is Maxwell. Yes, right.
Done, sir.
Very good. Sham Saif.
Done.
Okay, thank you.
Yes,
Saif, are
sir.
you done?
Done, sir.
Okay. So here is a formula for you. The first speed, which I called root mean square speed, and the second comes to be most probable speed. And most probable speed, most probable speed. Whenever you heard of it, most probable speed, that means this is the speed of the gases in which number of molecules of gas is the maximum number of molecules of gases travel or moving with this speed. Okay, so Maxwell give another formula for amps, that is equal to 2 PV upon M, and you can write 2 RT upon M. As you know that PV equals to nRT, and for reference it took n is equal to 1, that is it is all defined for number of moles. N is equal to 1, this formula PV equals to RT, so I'm just replacing it PV by RT. So another formula, third velocity, that is average speed. Average speed, you know that how to find average speed, that is equal to average speed is equal to v1 plus v2, you can write, or n1 v1, whatever you want to average speed. Okay, like you can v average is equal to v1 plus v2 plus v3 plus dot 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 upon n1 plus n2 plus n3 dot dot dot. This is average velocity. Or yeah, Maxwell gave another formula, V average is equal to under root of 8 RT upon pi m, or instead of RT we can write PV also, 8 PV upon M. You can write this. Okay. Done, Ifra?
No, sir, whereas Python, when you have written average speed 8 PV by M, you have not written pi.
Oh, I just forgot to wrote it. So if you are done with this, then let me know. Please do
Done,
reply.
sir.
Etasam, done?
Done,
Very
sir.
good. Okay.
Yes, done, sir.
Okay, thank you. And now I'm moving to the next question part. Whatever we have studied in this lecture, we are going to do some question, calculate. the kinetic energy of 8 gram of helium at 27 degrees centigrade. If you are unable to solve it, then let me know. I will explain it each and every question.
So what is the value of ideal gas constant?
R, that is if you are calculating kinetic energy, that is equal to 8.314 joule per mole per Kelvin.
Yes.
Yes. Ifra, what is your answer?
So 870 joules.
870.
1870. 1870.
Okay, let me solve it. So for kinetic energy in terms of this is molar mass given, this is given mass. So from here we can easily calculate number of moles. Number of moles is equal to given mass upon molar mass. Given mass is 8 gram and molar mass of helium, that is 4. So here it comes 2 moles. So for kinetic energy, I am going to apply the formula that is equal to 2 by 3 nRT, right? Sham, Saif,
Yes.
and
Yes.
okay. So
What
2
is
by
R?
3 number of moles is n.
It should be 3 by 2, right?
The value the 3 by 2. Oh, sorry. I just wrote it in inverse. Okay, so 3 by 2 and number of moles n equals to 2, and we take R as 8.314 because here is kinetic energy, or generally we express kinetic energy in joule, and for temperature you need to convert it into Kelvin. In Kelvin it will be 300 Kelvin or not. So very good. So here you can easily calculate 2 will be cancelled by 2, and from this 20 uh, 8.314 will be 813.4 into 3, and here it is also 3, that will be 9. 9 into 8.3 813.4 joule. You can multiply it. Whatever comes will be your answer. Like I think it will be, if we multiply 9 into 813.4, that will be equal to 7320.6 joule. Right, Ifra?
Yes.
Saf,
Yes.
Tusham, if
Yes,
you are
sir.
done with this, then let me know. I'm
Yes,
going to
sir.
change the slide and give another questions.
Finish, sir.
Tusham,
Yes, sir. Done, sir.
okay, are you done? Okay. So another questions come calculate the ratio of Vrms of O2 and N2 if the ratio of their temperature is 1:2. Just think about it. If you are unable to do anything about it, let me know. Whatever is given VRMS, calculate the VRMS ratio. Just see the formula. Which formula can you apply easily?
So which formula we use?
We are going to use the formula in which temperature is given. Okay, so here you can easily use VRMS for O2. I'm writing it VO2 upon VN2. This V represents basically VRMS. Okay, so in which formula we have temperature in terms of this one,
Okay.
and then take the ratio. Ifra?
Yes, sir, I'm solving. I'm taking the ratio.
Okay. Solve it. What about you, Saf?
I'm also doing.
So can you please show the question again? I want to see the ratio of temperature.
So what you just said, Ifra, I couldn't hear.
Sir, I'm solving. Sir, can you show the question? I want to see ratio of temperature.
Okay.
One.
Okay.
Sir, the R is same, right? 8.314.
8.314. Yes. R is same. Na? It can be cancelled. It will be cancelled, not can be. It will be cancelled. If you're done with the question, let me know. What is your ratio?
Yes, sir, just 1 minute.
Okay.
Sir, I got under root 7 by 16.
Under root 7 by
16.
Uh, Basically, you got this, right?
Yes, yes, sir. Yes, sir.
So the answer will be this,
Yes, sir.
and you can write it like root 7 is to
Yes, sir.
4, or you can also write it like 1.3 is to 4, 1.73. Basically, under root that will be wrong. Just write it like root 7 is to 4. Seth, what about you?
One minute, sir. I'm going to finish it.
Okay. Pi, if a pi will be cancelled, na? Which formula you are applying? Root 3 upon root 3 RT upon M, right? Here we in VRMS, we don't have pi, right? Ifra?
Yes.
Okay, taking longer than usual time. I'm writing another question for you. Saf,
Yes, sir.
are you done, or should I tell you how to
I
do it?
do got root 7 by 4.
Your voice is lagging.
I also got root 7 is to 4.
Is to 4.
Yes, same
Very good.
as
Then. Same as Itasam. What about you, Ifra?
So there is some calculation problem, so I am doing the question again.
Okay. Very good. Atashan, very good.
Thank you.
Ifra,
So just sending answer on it.
okay, sending answer. Saif, what about your answer? Very good, Ifra.
1 minute, sir.
Okay. So, Saif, see here. According to the question, VRMS of A is equal to VRMS of B. So we are going to apply formula under root of 3R temperature of A upon molar mass of A, that will be equal to 3R. This is constant. This is same for both the number 3 and the constant R, TB upon MB. Now do a square both sides. Squaring both sides, we will get 3R, and temperature for A is 400 and molar mass of A is 40. Here 3R and temperature of B is 60 given, and we need to calculate, that is atomic molecular weight of B. Now you can see 3R will be easily cancelled, and 0 for 0 is cancelled, and for 40 it will be cancelled, and for MB equals to, you can cross multiply it and you will get 6 gram per mole, or you can get 6 gram, right, Saf? Okay, can I change the slide, Saf? Okay,
1
I'm
minute.
writing. Okay, take your time. Do I need to go to the previous slide?
No need.
Okay, thank you. So after writing this question, let me know, please. I have questions for you.
Yes, we're done.
Okay. Etisham and Ifra and Saf. Do you know which is second member of alkyne? Have you ever heard of term alkane, alkene, alkyne?
Yes, sir. We studied
Yes.
that in 10th.
What is the molecular formula of second member of alkyne?
Sir, ethane, right?
Uh,
That is alkane.
Propine.
Propine,
Propine.
not ethyne. Ethyne is the first member, right, Ifra?
Yes.
Ethene is the first member for alkene, and ethyne is the first member for alkyne.
Second number is methyne.
is
Methane.
propine. Prop, that means third. And
Second is
that
methane.
means number. Sorry, what you just said?
Sir, methane is first, right? For alkane.
That is for alkane.
Yeah.
That is for alkane, methane, ethane, propane, butane. But when it comes to alkene and alkyne, the first member is ethene and ethyne, respectively. Alkene, alkyne.
Yes.
Okay. So, can you, any one of you, can you tell the chemical formula or formula of second member of alkyne, that is propine? So I'm writing here for the hints. Second member of alkyne will be C3H4. The question is as easy as the previous one. In the previous question, we need to calculated molar mass of B, and in this question, we need to calculate temperature. For SO2, the temperature is
C3H4. Yes.
C3H4, right?
Yes.
Yeah. Okay, thank you. And it is talking about average speed. So be careful while applying the formula. Just don't apply this formula because it is for root mean square speed.
So do we need to convert the temperature into Kelvin, or it can mean Celsius?
Yes.
Kelvin.
Yes.
Yes.
What is your answer? Five, 5K, 5,000 or 5 Kelvin?
So just okay.
Just 5. That is the wrong answer. You have done mistake in calculation that you. That is wrong answer too. Okay, let me know what is the molar mass of C3H4.
Sir, it's 640.
Yeah, your voice is lagging too much.
Sir, 40, 40, 40, 40.
44,
40, 40, 40.
40, right?
Yes,
And
sir.
what is the molar mass of this?
64.
Okay. Where are you, Saif? What about you?
So we use the formula under root 8 RT by
Yes.
pi m, right?
8 RT upon pi m, right? What you just said, Saif?
Nothing, sir. I didn't say anything.
Okay. Look here. Here is the formula V average is equal to under root of 8 RT upon pi m, right?
Yes.
8 RT upon pi m. Now see, average velocity of SO2 is equal to average velocity of C3H4 is given. So according to the question, I'm going 8 RT. Temperature for SO2 is given is 527 degrees centigrade, right? So here we are going to add 273 and we will get 800. And pi and molar mass of SO2 we just calculated 64. Again 8 into R into temperature we need to calculate for C3H4 divided by pi into molar mass is 40. First we need to do squaring both sides, so root will be cancelled. Squaring both sides, root will be eliminated easily. Okay, now you can see 8R into 800 upon pi into 64, that will be equal to 8R into T and pi into 40, and we can easily cancel it 8R pi, and you can I'm solving it, just simplifying it. 800 upon 64 is equal to T upon 40. So T will be equal to 800 into 40 divided by 64. Now you see 8 8 is 64, 8 5 is 40, and 8 into 100 that will be equal to 800, and 5 into 100 that will be equal to 500 Kelvin temperature. Ifra, where you?
Sir, I have taken wrong molecular mass of second
Exactly.
number.
That's why I asked about molecular mass first. And what you just where you went wrong at the Sham?
Checking, sir. Sir, calculation mistake, sir. I went till the last step, but cancellation part.
Okay. Ifra done.
Yes.
Saif.
1 minute.
Okay, I'm sending the slide. If anyone writing, let me know, please.
1 minute, sir.
Okay.
Hence,
Okay. Seth, after, if you are done, then let me know. Done.
Yes, done, sir.
Okay, thank you. Moving to the next question. The most probable speed of 2 gram of hydrogen is 800 meter per second. Calculate kinetic energy of gas. It is a very good question. We need to do a lot of questions.
so which formula?
What you just said, Tusham?
So which formula we have to use?
We have to use for MPS. First, calculate VMPS, most probable speed. Most probable speed, we have two formulas where it went here. Most probably 2 PV upon M and 2 RT upon M. It's better to calculate this because just focus here what I am going to do. For kinetic energy, we have two formula. First, the formula is kinetic energy is equal to 3 by 2 nRT, right, Saif?
Yes.
Ifra? Now see, kinetic energy is also equals to, or PV equals to, if you remember, PV equals to 2 by 3 RT. I am going to show you for the formula of kinetic energy. PV equals to 2 by 3 KE. Here is the formula, right?
Yes.
3 by, what was it? 2 by 3 or 3 by 2? 2 by 3.
Yeah.
2 by 3 KE. And here is formula for MPS, that is equal to under root 2 PV upon M. We need to calculate kinetic energy. So for kinetic energy, we can write 3 by 2 PE PV. Just try to understand this formula. We don't need to apply this formula, and neither we can calculate kinetic energy directly. So with the help of MPS, we can get easily the value of PV. And if we get the value of PV, we can easily put it here and calculate kinetic energy.
Yes.
Got it, Etasham?
Yes, sir.
Saif,
Yes, sir.
Etasham,
Yes, sir.
am
Clear,
I
sir.
audible to you?
Yes, sir. Clear,
Okay,
sir.
then calculate. Okay, Ifra.
Yes, sir.
Okay.
So the 2 GM is pressure, right?
2 GM. Where is 2 GM?
Yes, the
2
MPS
PV.
in question.
MPS. No. This MPS represents most probable speed. Are you talking
No,
about it?
no. In the question, the
2
MPS
gram.
of
This is gram. This is 2 gram. That is molar
Okay.
mass is given for hydrogen. Hydrogen is S2 and molar mass of S2 is 2 gram. Basically, this is mass. This mass is given.
Yes, sir.
Sir, I got PV as 20 root 2.
The wrong answer, I think.
root 800, under root 800. Sir,
That's
this
so wrong.
hydrogen, right? Yes, sir. This means. Sir, 10 root 2.
No.
320,000. different answers.
So just see here. I'm going to apply formula. MPS is equal to under root of. Let me know. It's 2 PV, I think, upon M. Right?
Yes, sir.
Now see, MPS is
Yes.
given. That is 800. Okay. Now under root 2 into PV upon M. M is 2, that is given. 2 and 2 will be cancelled, and here 800 equals to under root PV. Now we need to calculate PV. So squaring both sides. Squaring both sides. Let us sum. What is the square of 8?
64.
80?
64, sir. 64.
64, and here 20 is given.
Yeah,
So
40.
after 40, and it is value of PV. Now kinetic energy equals to what? Kinetic energy equals to 2 by 3. 3 by 2 PV. 3 by 2 P into V. So you can calculate it like 3 by 2 into PV. Value of PV equals to 64. 4 times 0. And here it can be cancelled out. 32, 4 times 0. And you can say 3 to the 6, 3 3 is 9 into 10 raised to the power 4. Right?
Yes. So joules, right? Unit.
Yeah. Joule. You can also apply the another formula to calculate it. After writing this, let me know. I will apply the second formula of most probable speed.
Done.
Thank you. Thank you. Saif.
Completed, sir.
Completed. Okay. Just see here, another formula for MPS is equal to under root 2 RT upon M. So here 800 equals to under root of 2 into R into T M. After squaring both sides, here we will get 800 and I can directly write it squaring both sides. Squaring both sides, we will get 64 into 10 raised to the power 4, right, is equal to 2 will be cancelled by 2 and it is the value of RT. And another formula of kinetic energy, that is equal to 3 by 2 nRT. Do you remember this formula too?
Yes, sir.
Now kinetic energy equals to 3 by 2 N. N is number of moles given mass 2 gram and molar mass 2. That will be equal to 1. So I'm putting the value of N as 1 into RT. The value of RT is equal to 64 into 10 raised to the power 4. So it will be cancelled by 32 times. 32 to the 64 and it will be again like 96 into 10 raised to the power 4 joule. Got it?
Yes,
So
sir.
it's not necessary. The question will be directly asked for on the basis of formula. The questions will be asked like this also.
Yes.
With the first formula, we will get value of something and then another formula will be applied and we'll get the answer.
Done.
Okay, thank you. Moving to the okay, let me ask. Saif, what about you? Done? Done?
Yes.
Saif, you are not audible.
Yes, sir.
Okay, thank you. Now see, there is a relation between which is RMS, that is root mean square speed. V average, that is average velocity, average speed, and there is MPS that represents most probable speed. Here, order of velocity or speed, order of velocity. I'm talking about order of velocity. That is basically in magnitude, RMS is maximum, then average, and then MPS. The value of speed is maximum in root mean square speed, then average velocity, and then it comes the lowest speed has that is most probable speed. Again, we are going to apply a formula. That is like this. Again, the same graph, fraction of molecule versus speed, fraction of molecules versus the speed or velocity. So if I am just pointing something like 1 and then 2 and then 3, and if I'm asking this number 1 2 3, what which speed it represents, the third the number third, the second, the first, which speed it represents, can you tell me?
I didn't get the question.
So I'm again asking the question at the Sham. I'm this point, this is 1. Which type of speed it is? RMS, V average, MPS? Which speed of the which type of speed is this represents number 2, RMS, V average, and MPS, and this 2. Got the answer? Got the question, or I need to explain it again? This number 1 2 3 is which type of speed it represents? Saif, do you got
Yes, I got your
do I
answer.
need to?
I got your answer.
Okay, you got my question or answer?
No question.
Question, thank you. What about you, Etasham?
Yes, sir.
Do I need to explain it again? If you need to, okay. Just see, I am asking that this point 1, it represents which type of speed. We studied about 3 types of speed, that is
Yes.
root mean square speed, average speed, and MPS speed. Then this points 1 2 3, it represents which type of speed, whether 1 represents RMS, and whether 2 represents average MPS, and whether 3 represents most probable speed. Can you answer it, or I should explain it?
No, sir. Understood.
Saif, any answer? Etasham?
Yes, sir.
Just see here, which one is representing, which point is representing the maximum speed? Let me know. The first point, second, third, which point represents the maximum speed? Saif?
I guess the first one.
First one. Just see, x-axis representing speed and y-axis representing fraction of molecules. So this speed is maximum, or this, or this?
So speed
Saif?
is T3. Sir. T3 is greater
Again,
than
think
T2
about
is
it
greater
in
than
detail.
T1.
3. Third one.
Sir, third one is RMS, second one is average, and first one is MPS.
Saif, what about you? This 3 point, which represents maximum?
Third one.
Third one, and we know the relation RMS is maximum. So third representing RMS, second representing V average, and the first representing MPS. Got it or not?
Yes.
Yes, sir.
Okay, write it. In the next lecture, we are going to end this chapter. So I had given you a question in the previous lecture. Did you solve it, Saf and Etisham?
Yes.
Okay. Did you send it to the to Niskash, sir?
No.
Okay, that's very bad.
Done.
Audible. Saif, are you done with this?
Yes.
Okay. Do you have any query about this class? Do you have any doubt regarding these topics?
No, sir.
Okay, Tasham, what about you?
No, sir. Clear, sir.
Clear. Very good. Thank you for today. Just
Thank you. Yes.
do you have NCRT? Do you solve NCRT?
Yes, sir. Yes, sir.
Or you use another book?
No, sir. NCRT.
NCRT, sir.
Okay, thank you so much. Write some question. I'm giving some questions from NCRT too. Okay, the assignment is from for board, NEET and JEE too. Okay, and here I'm going to give some questions. So the next class is on coming Tuesday. So here is a lot of gap, like as today is Thursday, then Friday, Saturday, Sunday, Monday, 4 days. So in exercise, I'm talking about exercise, back exercise in the NCRT. You can do question number 1, 2. Question number 23. And let me
Yes.
okay. Basically, you just don't need to do it from question number 23 up to 23, not 23, but 21. You can easily do it. I have taught it all about these concepts. Okay, there will be some questions if comes, then leave it, and we will first discuss these questions, then we will move to the next topic. Okay, so it is better for you to do attempt all the questions. It's easy.